LLMs are good at generating responses, for example, asking it to come up with fake video game characters or code examples. However, it's more often than not very difficult to precisely control or constrain the output to be the exact format and content you want, which could impact downstream workflows that expect the output to be a certain format or style. In the meantime, many LLM wrappers and APIs recently came out that implements guided decoding or generation, but they're not based on real-world user needs and requirements that developers are facing on a day-to-day basis. As a first step in this work, we conducted a survey with developers who directly work with LLMs to answer these 3 research questions. What are the real-world use cases that need output constraints? What are the benefits and impacts of being able to apply constraints? And how would users prefer to articulate or communicate their constraints? To answer the first question, we created a taxonomy of different types of constraints that developers would like to apply over LLM outputs. In a nutshell, users very frequently need low-level constraints, which mandate that the output to conform to a structured format, such as a JSON object with custom schema or key-value pairs, and make sure that the output is at an appropriate length. In the meantime, developers also need to be able to apply high-level output constraints, which involve semantic and stylistic guidelines that users would like the model to adhere to without hallucinating. Notably, we also found that developers often have to write complex parsing and plumbing code to handle ill-formed LLM outputs, which is a chore that could be simplified or even eliminated with output constraints. In addition, being able to have LLMs follow constraints to the teeth could also help designers and developers meet UI requirements, for example, by constraining the length of the output so that it fits into existing UI presets. Regarding the last question, we found that developers prefer using graphical user interfaces such as togglers, sliders, or knobs for applying low-level constraints, as it would give them more perceived control, whereas they prefer to stick with using natural language and prompt for articulating high-level constraints. To address some of the use cases we identified in the survey, especially the low-level ones, we also introduced a tool called Constraint Maker that helps people build and prototype constraints. For example, you can specify that the output should be a JSON object, and the JSON should have 3 key value pairs, each with a different data type. In the end, the output of the LLM would exactly match the requested format. Please check out the paper for more details on the UI, the implementation, and a set of preliminary user feedback on this tool. Thank you for watching.